Hello and welcome to Lockdown Mathematics. Today we'll be looking at more further examples for algebra. So the first thing we'll be doing is solve for x. In this particular problem, in question 1.1.1, we have x squared minus 4x plus 3 equals 0. The first thing you're going to do is you're going to factorize this into x minus 3 and you're going to factorize it into x minus 1. It's a fairly simple problem, and you're going to equate both factors to 0 for this factor and that factor, and you'll see that we get x is equals to positive 3 or x is equals to positive 1. Okay, moving on to the next question. We have question 1.1.2, and over here notice that it says correct to 2 decimal places. Earlier on in my previous videos, I told you that whenever you're dealing with 2 decimal places that you should use the quadratic formula. In this case here, we got a is equals to 5, b is equals to minus 5, and c is equals to positive 1. Okay, now what you'll do is you'll substitute these respective coefficients into your quadratic formula like so. So here your a is 5, your b is minus 5, and your c is plus 1. Right? Doing the appropriate substitution will give you 1 mark. Simplifying that out will get you another mark. And if they say to 2 decimal places, then you will put x equals 0.72 and x equals 0.28. But if they say leave it in surd form, then you will leave it as this answer here. Okay. The next section we'll be dealing with is going to deal with an inequality. Okay, so for this inequality, we know it's greater than 0. Right, so you got your parabola. Here's your 2 roots. Okay, and we know that our answers lie on the outside, so therefore I'll have 2 answers as part of my inequality. Okay, so what you're going to do here is you're going to factorize this expression. Okay, you can use 5 and 2 as your factors, so you'll have x and 5 in one bracket, x and 2 in another, and the bigger number will take on the negative sign here, so x minus 5, and the smaller number will take on a positive sign because minus 5 plus 2 will give you minus 3, and this is greater than 0. Equating each bracket, we can see that x is equals to positive 5 or x is equals to minus 2. Okay, and so here you'll have minus 2, here you'll have positive 5. And so now you know your answer is x less than minus 2 or x and, it's not or, sorry, that will be and x is greater than 5. So you must include both these answers. Okay. Right. So moving on, we got an expression here for question 1.1.4 where you got a square root, where you have a square root. Right? So just assuming where we stopped here. What you're going to do here is you're going to square both the left hand side and the right hand side. If I square the left hand side, 3 squared will give me 9, and root of x squared becomes x. The square root disappears. Okay, and then where you got x minus 4, you're going to have x in brackets. Don't forget the brackets, guys, because the brackets will tell us whether we have to FOIL and get 4 terms, or if you remove it, you will have just x squared minus 4 squared, which is incorrect, right? So this will be all round squared. Okay, so over here you got x times x, that will give you x squared. X times minus 4, give me minus 4x. 4 times minus x will give me minus 4x. And 4 times 4, well, negative 4 times negative 4 is positive 16. And this is a 16. This can be simplified to x squared minus 8x. I'm going to take this 9x here across, and it will become minus 9x. So minus 9x plus 16 equals 0. And so you can further simplify and solve this problem like such, where we got x squared minus 17x plus 16, and that will give you x minus 16, x minus 1, and letting this factor x minus 16 equals 0, we get x is equals to positive 16, and letting this factor x minus 1 equal to 0, we get x is equals to 1. Okay, so the next thing we're going to be dealing with is simultaneous equations, and I told you that this is where you should score marks. Okay, so suppose that's equation 1 and this is equation 2. The first step I said is to make either x or y subject of the formula of the easiest equation. So in this case, I'm going to stick with equation 1. So if I rearrange the equation, I'm going to make y subject, and y is equals to 2, well, negative y is equals to 2 minus 3x, positive y will be 3x minus 2. We just swap the positions of the 2 and minus 3x. Okay, and so this will become our new equation 3. You will then take equation 3, substitute it back into the unused equation, which will be equation 2. Wherever I see y is what I'll substitute in, where we have 3x minus 2. So this will be 2 times 3x minus 2 all around in brackets. Remember the brackets so you don't mess up the sign and the multiplication. And then you can solve this quadratically, or you can use the quadratic formula to get your x values. You'll get your x values and sub them back in the easier equation to get your corresponding y values. And so if we scroll down, you see question 1.2 done in the same way. So here's equation 1, there's equation 2, there's equation 3. Keeping your brackets, 2 times 3x is 6x, 2 times minus 2 is minus 4, and then the 9x squared is 9x squared, and that's equals to minus 1. Grouping everything onto one side, you get 9x squared plus 6x minus 3 equals to 0. So 3x squared plus 2x minus 1, we can take 3 as a common factor out, and that's how you get this expression. And then you can factorize that using your calculator or just by using the factors of 1 and 3. Okay, and then you can solve for x, and you'll get 1 over 3, and x is minus 1. Substitute this back into the easier equation, which would be this, equation 3. And notice that if you substitute that in, 3 times 1 over 3 will give me 1. 1 minus 2 is minus 1. Minus 5 times 3 is minus 15. No, sorry. If you substitute minus 1 times 3, you'll get minus 3. Minus 2 is minus 5. Okay, so that's how you get minus 5. Okay, so going back up. Okay, lastly but not least, we got a problem here dealing with exponents. So here we got 3 to the power 9x equals 64, and we got 5 root p equals 64. So calculate without the use of a calculator what the value of 3 to the power x minus 1 all round cubed, right? This is a 3, that's x to the minus 1, divided by the square root of 5 raised to the p. What is that value? So simply what you're going to do here is first write out this equation here and solve for x. Right? So you're going to solve for x here. Right? You know that you got 3 to the 9x. You can use natural logarithms to solve for that. And then you got 5 root p equals 64. So you can therefore find the value of p. Right? And so if you got the value of p and the value of x, you can substitute it into this equation and problem solve. But let's go to the solution. Okay, so here is our expression given to us. Here's an easier method of doing this. So we can rewrite this expression here. So here you've got 4 cubed, here you got 3 to the 3x cubed, and the cubes cancel on either side. And so here we're going to be left with 3 to the 3x equals 4 as one part of our equation. And then here, if you take the square root of 5, you can take the square root on this side as well, and you'll get square root of 64. And therefore, we see that root 5 root p equals 8. Okay. And so trying to evaluate this expression here that was in the question, you can multiply the 3 inside to the x minus 1, and then you can isolate the 3 to the negative 3, which becomes, so we know 3 to the negative 3 can become 1 all over 3 cubed, which gives me 1 over 27. Right, so that's how I'll get the 27 here, and the 3 cubed x on the top. And we know a value for root 5 root p, which is 8, and so I can simply substitute it in and solve. Okay, so I hope this video was a good help to you, and if there's any sections or questions you're unsure of, drop a comment. I will be glad to look at your questions, read up on it, and try and provide a solution for you, or do any other section that you need some help with. So don't be afraid to share a comment or share a link to your problem, and I'll open that link and try and make a video as soon as possible for you so I can help you prepare for your exams timeously. Okay, so until then, stay safe guys, keep working hard, and y'all can do this. Goodbye.